In this video, we're going to look at what types are in the Analysis API. This is part of a video series where I'm speaking about and sharing the different pieces of the Analysis API. So let's start and review by looking at the different phases of the Kotlin compiler. The first thing that a Kotlin compiler does is that it takes your source code, and what it does is that it creates a tree, a PSI tree, which represents the syntactic information, the syntactic structure of your source code. Each node in here is an element in your source. The next thing that it does is that it performs semantic analysis. There's information that's not in this PSI tree, and the semantic analysis does type inference underneath the hood and does a lot more things. So let's look at a very basic example of this. Here I have an abstract class and an implementation with the check method. And what I could do is create a PSI tree of this. And the PSI tree looks like this, where at the root that I have a KT file. Each element here is prefixed by a KT. And this is just the part of the tree which is representing the implementation class there and the method, which is check. So when you look at this PSI tree, the way I could do analysis is by grabbing one of these elements and providing it to the Analysis API. So I could take this KT file, and what I could do is provide it to the Analysis API, and then I could also get a result from it. So let's look at how this works. So the Analysis API, the way it's designed is that on top of these elements, PSI elements, it provides me with extensions. And these extensions give me access to all of the analysis information, semantic information, expression types that the analysis has performed. So here's an example where I'm going to grab a KT element and I'm going to give it to this analyze method. This analyze method is the simple API. You could give it any type of element that you want, a KT file element, you could give it a declaration, expression type, and in this lambda block right there is where I could get information. I could grab the symbols from there, I could call methods to resolve types in there, I could do diagnostics in there also. So I could grab the symbol. This symbol represents a KA symbol. So what does this Analysis API look like underneath the hood? Underneath the hood, it looks like this source code. What this is that this analyze method is the API and takes in two parameters. The first parameter is a KT element, but usually what happens is that you could also provide it a module, a KT module, and there's an API to build this KT module. The KT module represents a bunch of, it could represent a group of declarations. You could do analysis on that whole module. So for example, in the Kotlin Swift export tool, there is something called an SIR module for it. And you could give this information, you could give this module to this analyze method. And again, you could also give it just one KT declaration if you want. So the second part, which is the most important part, is this action, which has a KA session. So internally, what this analyze method is doing is that it's creating this Kotlin analysis session. And this analysis session underneath the hood is just an interface. This is the entry point for analysis. So in the Kotlin Swift export work, this was extended to create something called an SIR session. So what this KA session is comprised of are providers that give me symbol information, type information, resolution information. It's also made up of checkers. So this is an interface with all of this information that it builds. And this is what a very simple analysis looks like. Now suppose I want to get information about the expression type. I want to ensure what the type is for the expression. And in this case, I am giving it a KT expression element, for example. And what this type represents is something called a KA type. And KA is a prefix that is known for Kotlin analysis. All types, KA session, KA type, KA symbol, they all have this prefix of KA, which is known for Kotlin analysis. So I could grab the type information with this KA type. And what this KA type, what this information is. So the KA type is broken down into different hierarchies. So KA type is the root, but there's also KA class type, parameter type, a capture type. It all depends on the type of element that I am analyzing. I'm analyzing in this case a declaration, but what if I was analyzing a class or parameter? So it all depends. The type of KA type that I get is going to be dependent on the element, and these are the different variations of types of KA types that I could get. So when you look at, for example, a string, in this case, I want to get information about the class name that's in there. So I could do it like this. I could do type.classID and then get the actual class name for the type that I want, and I could do like comparison on it, for example. I can also compare types if I want. So suppose I have an expression type like this, and there's a second KA type that I want to compare it to, and I could do semantically equals, and I could do a comparison like this. So it provides me with an API to do that. The next thing that I could do I could compare things by asking, is one type a subtype of another? So there's an API called is subtype of, which is provided to me by the Kotlin Analysis API. So I could do different comparisons like this, but I could also build types if I want. And I could build KA types. And the way you do that is by using this method called build KA types. And you'll see there's something called default class IDs. There are class IDs for integer, for a double, for a string, and this is for integer. And what it builds is an int type, so which represents an int type for a specific variable. I could also specify when I'm building these types whether they are nullable. So the way you could do that is by using this API like this. Nullability in this case is KA type nullability, which is a constant. So you have the ability not just to compare KA types, you could also build KA types. And this is what the Analysis API provides me. So we looked at how to do analysis, how to get symbol information, how to get type information such as this, and how to build types. Next thing we're going to look at is resolution. Right? How is like function resolution done? How do you also get diagnostics? What if an error happens? And you could also specify the severity of the error. And we'll look at that next in the next video.